Seems like a good time to go ahead. So thanks everyone for attending today. Hope everyone's staying safe and staying healthy wherever you are in the world. I actually did a little bit of wakeboarding this weekend, and my body feels like it got run over by a tractor trailer. So it is true what they say about getting older. A few things before we go ahead and get started. Just one minor piece of admin. All of these talks do get recorded and they are being posted to our YouTube channel. So if you just Google Kaleido Blockchain on YouTube, you'll see a curated list of all the Tuesdays and walkthrough Wednesdays that we've done in the past. We've covered tons of features like event streams, private document exchanges. We've done the stuff around the keys before, all the integrations and configurations available. So if there are topics that you are interested in, all of that material is curated and available now on YouTube. So today we're going to focus fully on account management and keys. I think there's 6 techniques that we're going to go through that I'll show you today on Kaleido. We'll go with the classic route of externally signing transactions. Just use MetaMask for that and a basic IDE. Then we'll go ahead and show you how to use our Cloud HSM service, actually keep those private keys in a piece of hardware on Azure, on AWS, or stand up a HashiCorp server on premise or in your own local data center. We'll look at 2 routes of creating accounts on your nodes, and then we'll look at the Kaleido managed wallet services, a basic wallet service, and then a HD wallet, hierarchical deterministic. So I just have a few slides to set the table, and then we'll jump right into the product and should be able to get everyone out by half past the hour. If there are questions, feel free to raise your hand or just chuck them in the chat, and I'll get to those asynchronously throughout this. So a few high-level touch points on Kaleido, built for modern business networks, very much use case and industry agnostic. We are the tooling, we are the infrastructure, we are the runtimes that let you basically take those building blocks and form your own full stack solution. So very applicable to finance, to supply chain, pharmaceuticals, healthcare, NGOs, etc. Second, the platform itself, both in the UX and the underlying APIs, radically simple. You'll see how intuitive it is to actually use the console, stand up, and configure some of these resources. It's equally as easy to program against all these endpoints. Simple, clean REST APIs under the covers for every single action that is accomplishable inside of the console. So all admin operations and all service interactions, there's a very, very easy, clean REST API behind it. And then lastly, very much built for the enterprise. So auto-scaling, HA, DR, best-of-breed clients and algorithms, you get those out of the box. Our idea with Kaleido is to try to really get you into that pilot and that production phase, not concerning you with these core crypto primitives, the actual runtimes of your nodes and your services, giving you this robust infrastructure so that you can easily and dynamically progress your project, decentralize your network, start spanning clouds and spanning regions, and then ultimately, ideally, get to a production phase where you can get real monetary benefits for your use case and for your industry. Just to give you an idea of kind of the flavor of customers that we have, you can see that this really does span all verticals and all industries. So we see, energy and finance majors, some large retail and finance institutions, entertainment institutions, and then various government agencies as well. Just to touch on the enterprise grade nature, we are ISO 27001 certified, tons of techniques around key management. We'll touch on the vast majority of all of those today. X509, PKI identity constructs built into the platform, SLAs and 24/7 support, subject matter experts on the Kaleido team, and then some of those touch points I just hit on, HA, DR, dynamic auto-scaling, preemptive deployment of VMs, business continuity and backups. All of these are available out of the box or on some of our higher tiered plans. And then the last thing I just want to touch on, we do have the basic pay-as-you-go software as a service route. We are essentially just going to incur the costs of your hosted runtimes. That's primarily going to be nodes, and there's some rather negligible costs for some of the ancillary services. But we also have a flexible array of packages that try to meet you at the stage of your project. So if you are in sort of the sandbox or just POC phase, we have really affordable packages for that. If you're an innovation lab or sort of in the R&D sector of your business, of your enterprise, We have sort of more encompassing, enterprise packages available where you can start leveraging some of the more sophisticated and elaborate constructs like HSM signing, for example. So if you guys are interested in more details on any of those, I'll put my email in the chat, and feel free to reach out offline, and we can discuss any technical or commercial topics of interest for you guys. So let's just go ahead and hop right into the product now. And if my audio is unclear for any reason, I've gotten some feedback that these are not the greatest headphones, so let me know and I'll just unplug them and use the computer to talk through. So just throw that in the chat if I'm coming through encumbered. So here we are inside of Kaleido. I've created a very basic business network, just a single region scoped on AWS, and I've stood up one environment, one blockchain instance configured with Geth and proof of authority. I have two nodes, just a single membership, node 1 and node 2, and we're going to go ahead and look at some of these techniques to sign. So the first one we want to look at is externally signed transactions. So this is what you would use with one of those Web3 libraries, Web3 JavaScript, Ethereum, where you want to keep those private signing keys external, whether they're in a hardware wallet or whether they're in cold storage or managed in whatever implementation that you're comfortable with external keys. I'm just going to show MetaMask for ease of simplicity, and I know it's a construct and a plugin that I would imagine most people are familiar with, and we'll marry that with Remix, which is the IDE that I'd also imagine most Ethereum developers are familiar with. So here I've clicked on my node, and what I need to do is I need to get access to this fully qualified RPC endpoint. So I'm going to go ahead and click this Connect App button, and it's going to ask me to generate some application credentials. So every ingress in Kaleido has boundary security on it. So whether you're talking to a node, whether you're talking to a service, any runtime endpoint has boundary security. So we need these strongly generated app credentials to have a secure TLS connection. So I'm just going to create a new set here, username, password. And what I'm concerned with here is this fully qualified string. This is what I'm going to use in MetaMask to create a custom RPC endpoint, a custom URL. So here we see the username, here we see the password, here we see the basic auth string, and then here we see base64 encoded inside of an auth header. All I really want to do is just copy this fully qualified endpoint, username, password, at the RPC endpoint. So these app credentials are ephemeral. Kaleido is only going to show them to you this one time right here. So as an operator, as an admin, you're responsible for the custody of these, generating new ones, cycling, deleting, etc. They're not stored on the server side. It's a salt hash verification on our end. It is very easy to use the APIs and use the console to generate new credentials, delete them, what have you. But the important concept is that these are not stored by Kaleido. So this password right here, you are the sole admin that can actually save that and regenerate it. So I'll copy this endpoint right here, open up my little MetaMask guy, and I'll go ahead and create a custom RPC. So we'll just call this Kaleido endpoint. Call it whatever you want for your environment or your network. And then we'll go ahead and just paste that right there, that fully qualified endpoint. Go down here and save that. And now it's injecting it into the Remix IDE. But we should see here that we have our Kaleido endpoint. And here's the private key, the account B05D. So that's what we'll see the transaction, the deployment, or the instantiation signed by. Okay, so here we are in Remix. Again, I think this is probably very familiar to everyone that we have here. I'm going to be using Solidity, and I'm just going to use this trivially simple. This is even has less logic than the other simple storage contract that we use sometimes. It doesn't even need an argument to there is no constructor actually. So all it does is has a store and has a retrieve method inside of it. So what we'll do is we'll go ahead and compile this guy, and then we can actually instantiate it using that MetaMask private key. So we've compiled it. Now we can go in here, and rather than using the local provider, we're going to go ahead and do the injected Web3, and it's going to use our Kaleido endpoint, and it's going to use that account that's hanging out in MetaMask. So all we should have to do here is click deploy, and then we should be able to use this store method to actually upsert a new value. So integrates with our MetaMask, we can confirm this, and then we should see in about 5 seconds, since I'm using Geth and POA, a successful confirmation of that transaction. Okay, so we do see that. We see our transactions recorded. And now we can choose to, if we wanted to interact with this contract. We can't retrieve anything because we haven't put a new value in, but we could put a new positive integer, 123, for example, and then issue a transaction. So there's the very, very basic, interaction using MetaMask and using externally signed transactions. And now what we want to do is we want to go, oh, I was in the wrong remix ID here, sorry. So we could try that again. That's why we saw that error. I had another terminal open. So if we did this again, sorry about that, we could compile this. I need to select a file. Oh, all over the place right now. Okay, so we can compile this guy, and then we could do that exact same interaction. Inject our Web3 provider, use this to count, and then we can deploy onto Kaleido. And this would work successfully. So there's the basic flow for external. What we want to focus on more in more detail is all the approaches that we give you on Kaleido, all of our services that kind of integrate with all these approaches. So the first one I want to point your attention to is actually our Cloud HSM service. So this is keeping your private, external private signing keys in an actual piece of hardware so that there's extra security, extra assurances that they can't be compromised, that they can't leak from that HSM. And we give you three different implementations to choose from. You can use the AWS Cloud HSM orchestration, you can use Azure Key Vault, or you can actually use HashiCorp with a signing extension. And this server can run wherever you want it to. This could run on your local laptop, this could run in another private cloud or on your own data center. So three different flavors of this, based on the existing cloud infrastructure that you have or the existing security implementations that you want to follow through. And this is going to work with two transaction submission routes. This will work with our REST API gateway, where we don't need a Web3 library. We have an abstraction of the Ethereum JSON RPC API. So using simple REST APIs and simple post calls, all you have to do is enumerate the Ethereum address, the account, and the corresponding private key that's held in this piece of hardware or inside of the HashiCorp. It can also work with a Web3 library, though, however. All you have to do is form that unsigned transaction object. The payload will get intercepted within our REST API gateway or within our Cloud HSM signing service. The unsigned object will be transferred here. It'll get signed, it'll get assembled, and then it'll ultimately go into the network as a raw signed transaction object. So if you do have existing code libraries, using Web3.js or Ethereum or Web3 Python, what have you, your favorite language, these are very, very easy to integrate and embed with the Cloud HSM signing service. Now, I'm going to show you the route to do with Azure. Azure is the lightest lifting here. The other two have considerable more configurations, but the actual, the actual end game is the exact same here in terms of that private key staying in a FIPS compliant piece of hardware or inside of HashiCorp here. So just to kind of give you the context of what we need inside of Azure, here I am inside of my Azure portal. And what we do is we create what's called an app registration. And this is what our client or our server-side app is going to authenticate into. Then we're going to give this app registration permission to talk to our Azure Key Vault, where the actual Ethereum key is held. So I have an app registration called Kaleido HSM Signing, and we see here that we have a client ID, we have a tenant ID, and we have a subscription ID. Kaleido is going to need to know about all three of these, and then it's going to need to know about a secret in order to authenticate into Azure and into this service. Once it's done that, all we have to do is give this service permission, or this registration, permission to talk to our Key Vault service. So we're going to see these three strings. These will need to be supplied to Kaleido, and then we'll need to supply the corresponding user secret. So it's going to be this value, U?8, with all the rest of the secret truncated there. So similar to kind of how we treat app credentials. It's a good corollary. And then the other piece, this should not be a surprise, is we actually need a Key Vault instance. So using the Azure Key Vault service here, we can create an instance of it. I have one called Kaleido Keys 1, and inside of it, I have a single key that I've created. I'll show you guys how easy it is to go and create these keys. So this is one that I've already created. It starts with 3 zeros, so the hex string 0x000, and then some other values. And so that's the key that we'll end up using to sign our first transaction here in Kaleido. It's trivially simple to create new keys. Just go ahead and give it a name that makes sense for your end user or your business department. Choose elliptical curve, and then just choose the Ethereum curve, SECP256K1. And then you also have the option to set activation dates, expiration dates, etc. So very, very easy to do that. And then you're just responsible for enumerating which key that you want to sign with here. So we'll go ahead and cancel that, and we'll go ahead and create the configuration object inside of Kaleido, and then we'll attach that configuration object to a cloud HSM service. So those two can work together and allow us to sign transactions. So back inside of Kaleido, we looked at the external route. Now we want to go ahead and use this cloud configuration setting down here at the bottom of our dashboard. And we're going to create a cloud HSM configuration. Now I did this earlier, so I'm hoping that they're cached. Otherwise, I'm going to have to do some copy paste. So this is the configuration object. This is not the service. This is where we're going to teach Kaleido about all those endpoints and that username secret inside of our app registration. So first, we're doing a cloud HSM configuration. We're doing it on Azure. And then we need to supply some strings here. So first we need the target address. Apologies, I'm gonna have to do a little copy pasting. So here's the target address, just vault.azure.net. So copy this guy. Then we need the user ID or the client ID. That's this guy right here. And these are all those values that we were just looking at with the app registration. So paste that. We need the secret. This is that U*8, the truncated value inside of Azure. So copy that guy. And then we need that object ID or the subscription ID. And then we need that tenant ID and the name of the actual Azure Key Vault service, the vault name. So there's the object ID. Last, we'll get the tenant ID and then just say Kaleido Keys 1. I think that was it. Yep, that looks good. Okay, so we'll go ahead and click finish. Create the configuration object, says it's inactive because we haven't attached it to a service. So now we want to use the key management tab here. We see node wallets, we see managed wallets. We'll touch on those in a moment. What we care about right now is this cloud HSM wallet. So go ahead and create a new one. Call it, Azure wallet or any arbitrary string that you want to use to identify these services. And now we're going to attach that config, that JSON object that we just created to this service. And this should take about 30 or 45 seconds to fully provision. Once this guy is up, we'll be able to interact with it. So while this guy's coming to life, what I'm going to do is I'm going to go ahead and create a contract project, and we'll use our Kaleido REST API gateway. We've touched on this a lot in the past, but just for any newcomers, a quick overview of what this service does. All you have to do is teach Kaleido about your source code, about your Solidity. So you can upload that, you can link to GitHub, you can give Kaleido the bytecode and the ABI. And ultimately what's going to happen is Kaleido is going to give you inside of the console an interactive Swagger interface to talk to your contract, and then very, very simple REST endpoints to talk to your different methods for invoking and querying the transaction. And this shim, this piece of middleware that we call ETH Connect, this is the abstraction of the Ethereum API. It's underpinned by Kafka for high throughput and reliable delivery, but it's going to do all of the nuances that new Ethereum developers may find very tricky. So the sequencing and the nonce management, for example, RLP encoding, type mapping, etc. So all you have to do is tell Kaleido about the source code, and then you can just submit very, very basic JSON objects to your relevant endpoints for your methods, and Kaleido will take care of the rest. We see here, though, that there's a lot of different ways to sign these transactions. So we can use an account that's on our node. We can do this, get attach in the JavaScript console and do this programmatically. We can let Kaleido create new accounts on a node. We can use HD wallets or Kaleido managed wallets, or we can have our keys off platform held in a cloud HSM service like Azure Key Vault or like AWS KMS, or using that HashiCorp with a signer extension. So I'm showing you this route right here using the key inside of Azure. So the first thing we need to do is create a contract project, create a namespace. Obviously, we're creating an Ethereum contract project here. So we'll call it simple storage, a very, very basic piece of Solidity logic, and we're going to import it from GitHub. So I'm going to click new compilation within this namespace, just call it version 1 of SS. And the idea with these contract projects is that you can iterate on your business logic, on your Solidity, and you can create many, many compilations within a single contract project. So once you harden that source code, you can very, very easily promote it to different environments within your network. This is a network level service or construct here, these contract projects. So they provide everyone with a holistic or transparent view into the source code, what they're executing on chain. So here we have a JavaScript repository. This is public, so if there are any Web3 developers out there that don't want to use the REST API gateway, this has tons of examples of using our HD wallet to sign or signing externally, and shows you good examples of all of that, all those Web3 APIs. So this guy right here, it just has a single variable, a positive integer. It does take an argument to the constructor when we instantiate it, and then it has two methods. It has a set and a get, and a redundant get right here. So it has two different queries with different names, and then a single set that needs the positive integer to be under 100. So we'll just take the endpoint of this code right here, this URL, tell Kaleido about it, and then we can auto detect all of the other parameters here. So go ahead and just click finish, and this guy will compile in about 20, 25 seconds or so. So now we can return to our key management service. We can click on our Cloud HSM wallet, our Azure integration that we created, and we see that this service has started up. We can now view the wallet. We can manage the wallet, delete it, change the name, restart the runtime, etc., see the logs, and then we can see the accounts that are inside of it. So as I mentioned, my guy was 3 zeros and then 16BE. So what we're going to do is I'm going to copy this onto my clipboard, and once that simple storage contract project compiles, what we'll do is we'll use this Cloud HSM, the private key held in Azure, to actually sign the instantiation of that smart contract, of that deployment. So this guy compiled, we can click on the compilation. So I'm within the project namespace, and we see that we just have a single compilation that I created here. See the ABI, see the bytecode, see any of the dev docs that are there. And then we have our source of truth. We have the endpoint, we even have the git commit hash here. So now what I can do is I can promote this into an environment. And again, the idea with these contract projects is, hey, promote it to your sandbox, promote it to your dev, iterate, 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 harden your application. Once you're good to go, you have your throughput, you have your performance, everything's acting as you expect. Then you take this exact same compilation, this exact same definition, and you easily promote it into your pre-prod, UAT, or production environments. So I just have a single guide, but felt it was worthwhile kind of explaining that. So we'll create a name for the definitions we call for these APIs, call this a gateway API, and then we choose where we want to deploy it, where we want to promote that compilation. So I'm going to create the APIs, I'll call them SS, shorthand for simple storage, and I will promote this into my dev environment. And now what we can do is we can view the API, view the gateway right here through the lens of node number 1. We'll see those core methods, but we haven't actually brought this to life. This is just a definition of the methods or the functions in that smart contract. What we want to do is use this root host method instead of using the default account on node number 1, the guy that we're actually sending this transaction to. We're going to go ahead and overwrite this value with our private HSM account here, so 0x00016. Okay, so this is using the REST API gateway, no Web3. Kaleido's doing all of that for you. We're submitting synchronously via Kafka, so we're going to wait for that transaction to be executed and the response to be returned. We can submit this asynchronously, kind of a fire and forget. You get an acknowledgement from the Kafka topic that it received the payload, and then it's going to buffer, queue that, and reliably submit it for you. So as soon as Kafka gives you the acknowledgement that it has your transaction, you're good to go. So it's a really nice construct to just asynchronously stream transactions, fire and forget. So I'm going to actually use this KLD register parameter here, and we can give this a human-friendly name. We don't have to use hexadecimal addresses. And then it did want a value to the constructor. So I'll just give it 30 since that's the date. Go ahead and invoke that method, that root host method. And this will bring that gateway API, that compilation, and it'll turn it into an instance of it, an actual on-chain deployment and instantiation. So here we can see the receipt, and we see the from parameter, and we see that it was signed by our HSM account, by that private key inside of Azure. So we can go ahead and close this guy. Here we are inside of the Gateway API in my environment, and I see that I've now created a new instance of that Gateway API. And I could create as many as I want. So if you're using, common business logic, maybe you just want to separate it or demarcate it, across different regions. If you're a multinational or different business sectors, very easy to take the same business logic, create multiple instances or deployments of that, and just give it a human-friendly name. Accounts payable, accounts receivable, Europe supply chain. Any example, there's myriad examples of how that could work. So there's the cloud HSM approach. Now we want to look at some of the approaches of signing the transaction using an account held on the node. So I'll show you the two routes that we have available for that. So go back to the dashboard, click node number 1. I'm going to generate a new set of application credentials right here for the, actually I'll just reuse these guys. Now I need to generate a new set of them. Regenerate. And I'm going to go ahead and do a geth attach using this fully qualified endpoint here. So we'll say geth attach and get ourselves into the JavaScript console. And then we can use the personal class to do some account management. So just type in personal. You'll see all these available APIs. So I only have an initial account here. This is telling me about the accounts that are on the node. It doesn't know about that HSM account, obviously. And we can just go ahead and use this API, personal.newAccount. And this is a nice route to go because you have full control over the encryption and the locking and unlocking of this account. If you create a node account using Kaleido, Kaleido is going to automatically unlock that for you. So I'll just give this an empty passphrase here. But the idea here is that this account is locked. So acting as an administrator, I've created a new account and I've locked it, ideally using, some more interesting entropy than just, hitting the return button. And this should manifest here in a second. I'm not sure why this is going so slowly. Okay, that took way longer than expected. But we see here that we've now created a new account on our node, and this account is locked. So if I try to sign a transaction, submit a transaction using this account, Kaleido is going to go ahead and throw us an error saying that this needs to be unlocked. So just a nice approach as an operator to, use that happy path of having accounts on the node, using that to sign, but also having full control over, if that account needs to be, locked or cycled or deleted. So go ahead and use the post method against our set function right here, and then we'll overwrite again that default node account. So using this guy, I think that's the guy that we just created, is it not? 0xd0. Okay, yeah, it's very similar to that one, so I got a little confused, but BD1F, BD1F, okay, cool. So go ahead and upload a new value for our set method, maybe give it 25 right here, and we should see an immediate error from Kaleido, authentication needed, password or unlock. So now we can just use that same module, personal.unlock account, right here. I think I still have that on the clipboard. Go ahead and unlock that guy, should say true, and then we can call this same method and this should work. So again, just an example of, acting as an admin, acting as an operator and having control using the JavaScript console of those accounts. As I mentioned, Kaleido will also call this API for you and automatically unlock the accounts. So if we go back to our node right here, click the dashboard, click node number 1, we see that we have a wallet right here. We can also access this wallet down here in our key management tab. So we can click the node wallets tab to access that as well. So go ahead and do that. I can click node number 1. You see that we have that default account that we were seeing inside of the terminal, 0BDD right there. That was this guy, 0BD, blah, blah, blah. And now we can create new accounts, letting Kaleido call those APIs for us and automatically unlocking those accounts. So there we've created a new one, 069D7. So we can go ahead and copy that, and we can make that same call inside of the REST API gateway. signing with this account right here. So this is, using the accounts on the nodes, it's very convenient. It's one of the least interesting approaches, but it's also a very valuable approach just in terms of its simplicity. So go back to our gateway APIs. We'll go ahead and click on our instance, view that instance through node number 1. And just another example, we can use that node account created by Kaleido instead of the account created by us using the JavaScript console. So again, we're just giving it a positive integer under 199, for example. And again, get POA, so this will return synchronously in about 5 seconds for all these calls. So that was successful. And now the last two approaches I want to show you using our Kaleido managed wallet service and a very interesting one using the HD wallet service. So the managed wallet service is very, very simple. Just go ahead and click this key management tab. We can create a managed wallet, and inside of it, we can create as many keys as we want. So I'll just call this example wallet. Go ahead and click next. Choose the type of wallet that you want. So we have the basic managed wallet. We also have HD wallet. I'm going to have to use the old console to show you guys how to do this one. But coming in the near future, we will see, all of our B2B stack, our document exchange, our app-to-app, our event streams, and our HD wallet functionality come into the version 2 of the console here. So just go ahead and click finish that. This will provision very, very quickly here. And then inside of it, it'll come with one default key, and we can create as many additional keys as we want inside of it. This is going to go with the exact same approach here. As soon as this service stands up, I'm just going to open it up. I'm going to copy key on the clipboard, and we'll go back in here, and we'll just call this set method again with a different key. So this works very, very similarly to actually using Kaleido to create new accounts on the node. One thing you can do here with these services, though, with these managed wallet services, the Kaleido wallet and the HD wallet, you can actually encrypt them with a master key. So you can have a master encryption key held in your AWS KMS service, not a SecP 256K1 key, an Ethereum key, but an actual master RSA key using whatever curve or whatever crypto primitives you want. So it gives you heightened security over those keys that are managed on the server side by Kaleido. It proves that you have the only asset that can truly unlock and protect those keys. So like I said, you get a default account inside of here, 6A41. So I can just go ahead and copy this guy onto the clipboard. It's going to interact with all of our token services and our data explorer. So as we sign transactions or transfer tokens or mint new tokens, whatever we're going to do, we'll be able to see a full audit trail and a full log of all those actions. So it's very nice in terms of kind of the logging and the transparency that it provides. But for this purpose, what we really just want to do is copy that on the clipboard. We'll overwrite this value that we just upserted, and then we can do that same sort of transaction. Maybe call it 98 this time instead. So again, these are synchronous submissions, so we're going to wait 4 to 5 seconds for this object to return. So there we see a different transaction hash, different block hash, and this guy was signed by that new account that we created in the Kaleido managed wallet. So the last thing I want to show is HD wallets. These are really useful for 2 different techniques. This is a key tree, deterministically recreatable using a master seed phrase or a mnemonic, 12 words, that correspond to the generation of the accounts and the private keys. But it gives you 2.8 billion unique Ethereum accounts and corresponding signing keys. So it's great for anonymity, single usage, just sign and throw away, work your way through the index. No one's going to be able to correlate any of the transactions to a common signing address. So really good in those circumstances. Maybe use this with a combination of Besu or Quorum for private transactions, and then sign with a one-time key. Really gives you heightened privacy and anonymity. But the other route is to use it for end user management. So you don't want all of your end users to have to have mobile wallets or manage their private keys. Don't want them to get caught up, with the nuances of Ethereum and with signing transactions, or just with the custody of those keys. So you can manage these on behalf of your end users. Very, very easy to kind of mirror this, integrate this with the AD or with the IAM system. Just say like, hey, user number 1 maps to account number 1, user number 2 maps to account number 2, and then you can very simply sign on their behalf. So really, really nice implementation, nice technique to do end user account management. And it's very, very easy to map the indexes of these accounts with your end users. So that's sort of a technique that we're starting to see a lot more often in Kaleido, and this also works seamlessly with our REST API gateway. So I'm going to go back to the old console, and we'll see the exact same Swagger interface available to us on this. We just won't have all of the new fancy next-gen V2 navigation. So I'm going to open up the services dashboard here, and I'm going to add an HD Wallet instance. I'll just use the default name that Kaleido provides here, and we'll give this guy maybe 30 or 45 seconds to come up. So that was kind of the high-level intro on the HD Wallet. And then if we look back at our REST API gateway architecture, we see here that we're just going to enumerate that HD Wallet instance. We're going to tell Kaleido about the wallet ID, because within our HD Wallet service, we could create many wallets. So again, if you want to compartmentalize or separate different geographies, different locations, or different departments, if you have a very large conglomerate or multinational or just a large enterprise, you could have a single HD Wallet service and then just have multiple wallets inside of it. So we're going to teach Kaleido in the REST API gateway about the wallet service ID, and then the actual wallet ID, and then the account inside the wallet that we want to use to sign. So hopping back here, this guy has come up. He's provisioned successfully. We're going to generate some new app credentials to securely access this instance. And what we see here, we see the endpoint. So we see our environment ID, we see the service ID for the HD Wallet, and then we see the corresponding string. What we want to do now within this namespace is we want to create one or more wallets. So here we see the wallet ID. Here's the mnemonic or the entropy or the seed phrase. This is what will allow you to deterministically recreate it. Again, it'll create deterministically all 2.8 billion of those accounts. And again, this can be encrypted with a master key held in your KMS or held in your Azure Key Vault service. So we'll go ahead and submit that. And here's our wallet, and we can now browse the wallet. So what we'll do is we'll tell Kaleido, hey, I want to make an HD Wallet call. Here's the service ID, here's the wallet ID, and inside of here, there is either 0 through 2.8 billion. I need to have the index. So very easy to peruse these, 0, there's the address, there's the private key. 1, there's a different address, different private key. 2, and we could go, we could go as deeply as we wanted inside of this, and there is there is an account and there is a private key. So we'll just sign with the very first one here. So we're going to sign it with this private key and this address, D8B54. Okay, so go ahead and cancel this right here. Open this back up. I'm going to copy this string right here. Let me close this, and I'll use the Gateway API in the new console. So hang with me for 1 second. So use the Gateway APIs tab, use the instance, view the instance. We can use the same app credentials, and now we can get that same Swagger interface here inside of the classic Kaleido console. So what we're doing in this KLB from parameter, this is where we enumerate that HD Wallet syntax. So HD dash service ID is the first one we want. So sorry for all the hopscotching. Let me go back to the HD Wallet instance here. Okay, so this string right here, copy that, and tell Kaleido about the wallet ID. We only have a single wallet ID right here, so it's this guy. But again, we could create multiple wallets within this service instance. Give it that, and then tell it the index inside the wallet that we want to sign with. We're just going to use 0. Submitting it synchronously again, waiting for it to be executed, and I'll just keep going down, 97. And then we should see that transaction receipt come back, and it will be that account that's held in the HD wallet, D8D54, the guy we just looked at. So we could use this, again, we can use this through all 2.8 billion accounts, but the really nice idea here is to use this for end user key custody and signing on their behalf, while also leveraging the simplicity of the REST API gateway. So those were 6 approaches right there that we ran through. External with MetaMask and IDE, Cloud HSM, 2 routes to create and lock or unlock on side of the nodes. The Kaleido managed wallet service with a nice integration with our indexing, token explorers, and data explorers. And then lastly, the HD wallet, whether for anonymity and privacy or for end user account management. So don't see any questions in the chat. One final piece of admin that I have for you folks. All of these recordings, they're going to get posted onto our LinkedIn page. So our marketing team has informed me that if you follow Kaleido on LinkedIn and you leave a thoughtful comment talking to us about your use case or what you've learned about key management or different approaches, we will send you a Kaleido t-shirt. We'll work with you offline to get your address and your shipping information, and we'll hook you up with the t-shirt. I cannot overemphasize how comfortable these are. This is the old American apparel fabric, so it is some of the softest cotton in the world. So not a huge ask if you do want to get your hands on some Kaleido swag or just a really comfortable t-shirt. So just go ahead and follow us on LinkedIn, watch for the recording, and then go ahead and please leave us a thoughtful comment, talk to us more about your use case or what you learned today, and we will be happy to send you a t-shirt. So thanks everyone so much for attending. I don't see any questions in the chat, so I'll give you 15 minutes back. One final thing, going forward, we are going to do a walkthrough Wednesday tomorrow, so we'll dig into some more of the 101 features of Corda and Ethereum. But in the upcoming weeks, we're going to feature some new speakers, some of our subject matter experts, talk you through sort of enterprise application architecture, talk you through cloud deployment orchestrations, talk you through some of the really low-level nitty-gritty details about node configurations, starting, stopping, configuring block times, etc. So it'll be cool to hear some new voices and really get to hear about from some subject matter experts. I'm going to throw my email inside of the chat super quickly here so that everyone has it. If you do have a technical question or you have a commercial question, we can take these offline. Yeah, so I covered, the question was, did we cover HashiCorp? I did it at a high level. It all works the same, Azure, AWS, and HashiCorp. HashiCorp is, the service, the key management service with a signing extension to do SecP 256K1 signing. It's the heaviest lifting in terms of the implementation and standing it up. So I went with the happy path and showed Azure, but we do have really detailed documentation showing you how to do all of that configuration. So if you just go to docs.kaleido.io, we have different sections for AWS, for Azure, and for HashiCorp. So there's my email. Feel free to reach out for anything technical, anything commercial. And I really appreciate everyone attending and hope you have a wonderful Tuesday and stay safe, stay healthy. Thanks again, and we will see you next Tuesday. Bye.